This is Mrs. Carnes, and this is our last video on solving multi-step equations. Let's go ahead and begin. We're going to take a look at what happens when you have the same variable, but you have it on both sides of your equal sign. So to solve an equation when you have variables on both sides of your equal sign, you need to get the variables on one side and solve like normal. So I notice in this example, I have a 4n and I have a 2n. One is on the left and one is on the right. I need to get them on the same side of the equal sign. It does not matter how I do that, but I have to move one of them. I'm going to choose to move the 2n. Since it's a subtraction of 2n, I'm going to undo it by adding 2n to both sides. When I add 2n to both sides, 4n plus 2n is 6n. 6n plus 2, because that doesn't change, is equal to 32, and those have disappeared. So now I have an equation that looks very familiar to us. So we're going to quickly go through this. First of all, we have to undo our addition or subtraction. In this case, it's the addition of 2. So we will subtract 2 from both sides, because remember, we're trying to get our n, which is now just one n, by itself on the left-hand side. When we do this, those disappear, and we're left with a 6n is equal to 30. We divide by 6 to undo the multiplication, and when we divide by 6, we get n equals 5. Now you know that you could go back and you could test this solution to make sure that it works by plugging 5 in for each of the n's in your equation. Let's go ahead and move on to something else. Sometimes you have an equation where there is no solution, and you have no solution if you cannot find any value that will make that equation true. So let's take a look at this example. Now you know once you see parentheses, the very first thing you need to do is the distributive property. So we're going to start with distributing that 3 through the parentheses and see what we end up with. 3 times 2m will give you 6m. And 3 times negative 1 will give us negative 3. That's our distribution, and that equals 7 plus 6m. Now, we notice that we have m's, but the m's are on both the left and the right-hand side of the equal sign. So just like before, we have to move them onto the same side of the equal sign. I'm going to take the 6m from the right-hand side, and I'm going to move it over to the left-hand side. And I do that by undoing the addition that is in front of that 6m. I'm going to subtract 6m from both sides. Now watch carefully what happens here. 6m minus 6m, those disappear. I'm left with a negative 3 on the left-hand side. That equals, there's a 7 on the right-hand side, and we now also notice that those 6m's also cancel out. And so what's happened is that the variable has completely disappeared. There is no m value anymore. And so we take a look at the sentence that's left over. The remaining sentence says negative 3 is equal to 7. Well, we know that negative 3 can never be equal to 7. There is never a time where 7 and negative 3 will ever be equal to each other. And when this happens, your answer then becomes no solution. And we would write no solution. And again, that happened because the statement that was left over was a false statement, and so we know that there will be no solution to this equation. Let's take a look at a different situation. It's not only possible to have an equation with no solution, it's also possible to have an equation with an infinite amount of solutions. We call this an identity. An equation will be considered an identity when it's true for every value of the variable. When every value that you plug in for the variable comes out to be a true statement, you know that you have an identity. Let's take a look and see what this looks like. In this example, I see that I have an A on the left-hand side of the equal sign. I see that I also have an A on the right and another A on the right-hand side of the equal sign. So using all of the steps that I know I have to get these two A's together. I have to combine like terms. I also see that I have a constant here and here that are both on the left-hand side. I must combine these two also. When we do that, we're going to end up with the statement that says 6A, because I don't do anything with that yet. I have 8 minus 1 becomes positive 7, and that's going to then equal 7A minus 1A becomes 6A, and then this 7 is left over that I have to continue to keep. So I have this remaining equation, 6A plus 7 is equal to 6A plus 7. Now, I combined like terms, but I still have an A on the left and an A on the right. So, as the steps tell us, I have to move those A's so they're on the same side of the equal sign. Once again, I'm going to move the A on the right-hand side over. It's a positive 6A, so I will undo it by subtracting 6A to both sides. Again, notice what happens. The 6A disappears here, leaving me with just 7 on the left-hand side of the equal sign. And the 6A disappears here, again, leaving me with 7 on the right-hand side of the equal sign. Now, since the A's disappeared, I know that there's something interesting that happens in this problem. I'm left with the statement 7 equals 7. But that can't be a solution because the variable is no longer there. So I have to ask myself, well, what does that mean? Does 7 equal 7? And the answer is yes. That is a true statement. 7 will always be equal to 7. And so in this case, we call this the identity. You can also say that you have all solutions or infinite solutions to this problem. Let's see if we can use all of the rules that we have learned in these 3 videos to solve this problem. First thing I notice is that I have fractions. I have to remember, in order to get rid of my fractions, I need to get common denominators. I'm going to put a 1 underneath this, and I'm going to make all of these common denominators. The common denominator will be 10. My first fraction will become 6/10, okay? My second fraction already has a 10 in the denominator. It will become 1/10, okay, or stay 1/10, okay? And the third fraction, to get 10 in the denominator, I'd multiply by 5, so I would end up with 5/10, okay? And finally, to get a 10, we would end up with 10/10. Since there's 10s on the denominator, I would go ahead and multiply everything by 10, and that will just make all the denominators disappear. The equation then you're left with is 6k minus 1k is equal to 5k plus 10. You now notice that you have like terms on the left-hand side of the equation. When you combine those, that becomes 5k is equal to 5k plus 10. And you now know that you have k's, but they're on both sides of the equal sign. We just got done learning that to get that taken care of, you have to move those k's onto the same side. I'm going to move the 5k from the right-hand side to the left-hand side by subtraction. When we do that, we notice, again, as we have seen before, that the 5k's disappear. This leaves me 0 is equal to, these disappear, and 10. So the last thing you have to ask yourself is, you know something specific happens here, and you ask yourself, does 0 equal 10? And you know that the answer is no, 0 will never equal 10. So for this equation, the answer is no solution. So you have seen lots of different examples of solving multi-step equations. If you need more help with these, go back and review the 3 videos that you have watched, or also you can go to the internet for more video options.